Question 9. In this question, all lengths are in meter. A particle P move in a straight line, and you have a particle P, it's move in a straight line, such as that T seconds after passing through a fixed point O. Let's say this is O, displacement is given by this. So here, after passing O, this is the displacement. Find value of T and when it's instantaneously at rest. Rest means V is equal to 0. So imagine P move through a fixed point O and suddenly stop. That is when V is equal to 0. Now, to relate between this is kinematics, displacement, velocity, and acceleration. If they give you displacement and you want to find velocity, what you need to do is you need to differentiate displacement. When they give you velocity, you want to find acceleration, then you need to differentiate velocity. When they give you acceleration, you want to go backward, you integrate acceleration. When they give you velocity, you want to find displacement. That is when you integrate velocity. Now, in this question, they give us displacement, which is this one. And when V is equal to 0, meaning we need to find V. So, S is equal to, we need to differentiate this. That will give us velocity. Now, for every differentiation of ln, if you have ln x and you want to differentiate this, it will be 1 over x. If you have y equal to ln, and then you have a function in that ln, to find dy dx would be 1 over the whole function times with the differentiation of this function. It's going to be 3. And your differentiation would be 3 over 3x plus 5. The same with this part right here. So 5, we just put it outside. And then 1 over the function, the whole thing. And then you differentiate this. Differentiation of 2t will be just 2. We differentiate this last part, that is just negative 5. Simplify this, we will have 5 times 2, that is 10 over minus 5. This is our velocity. And when V is equal to 0, that is, now we can just find our t and make it as a subject. 5, 2t plus 1 equal to 10. Open the bracket. 5 times 2t, that is 10t, plus 5 equal to 10, and then 10t will be 10 minus 5, so t will be 5 over 10 or 1 over 2. Okay, this is 4-mark question. When they give you displacement and to find velocity, you need to differentiate this. That is going to give you 2 marks. And when you understand instantaneously at rest mean V is equal to 0, and then when you put V here and you find your t in 1 over 2, that is going to be another 2 marks. Find the distance. We know that every time we have velocity time graph, the area under the graph will be the distance. Velocity is, now you want to know how far it has been traveling from 0 to 2. Basically, it's integration from 0 to 2 velocity function. But if we plot the graph of time, this is graph of time, when t is equal to 0, our v will be 0 here. All of this is 0, so our v is negative 5. If here is 0, then negative 5 will be here. So that is our starting point. And when t is equal to 1 over 2, that is when v is 0. So let's say this is 1 over 2, this is our v. And we want to go until 2, right? So if t is equal to 2, then our v, so this is just 10 over 5 minus 5. So 1 over 1 will be 2 minus 5, negative 3. So it's going to be negative 3, which is somewhere here. So maybe this is our graph. Now to find the distance, we need both of this area. When we do integration, it will be from 0 to 1 over 2 of the function plus this region 1 over 2 and 2. Integration of 1 over 2 to 2. Integration from 0 to 1 over 2, 10 over 2t plus 1 minus 5. This one will give me 0.9657 plus. So notice that this one is giving me negative 2.918. Okay, because it goes backward, velocity negative, it means it goes backward. Now, since I want to find distance means I need to add both of this number. 3.8837 is my total distance. This is the marking scheme. This is 4-mark question. When you understand that you need to go from 0 to 1 over 2, and then from 1 over 2 to 2, and then you add them together. So this is your total distance.